All right, so I think we are, I think it's good there. So let me close out. All right, so yeah, so we are live on Facebook. Um, so this is our CSEC marathon, the one that I said we will do. So we started at, we were actually supposed to start at 9, but you know, we started at Guyanese 9. So here we are, starting on Guyanese 9. So the video will be up after after we've completed it. So yeah, so that's how things will go. So we're live on YouTube as well for those of you who would like to hop over to YouTube and look at it. Do you have for an NGSC? Unfortunately, not this year, probably next year. It's Sorvelo on Paris who is doing some lovely YouTube videos for NGSC. So I could check out him on YouTube. I think his name is on YouTube is um VPGY. Yeah. All right. So I'm here with some of my students. A few of them, a very handful of them, who are brave enough to come live as well with me. Uh, so they will you'll be hearing the voices of them as well throughout the live video. A few of them, a very few, handful. So you'll be hearing their voices throughout the video. All right. The purpose of this live is to, get some practice. You never know how many of these questions or type of these questions you may come across in the exam. And, they say, oh, you saw us or work this on Facebook live a day, and, you score, you got the marks of those questions. They never know that those marks that you get can determine if you get a passing grade or a failing grade. So yeah. So let's go. So this live will take two parts. I'll be working on paper two kind of questions and some paper one questions. Paper one type of questions, I should say. All right. So let's head straight into it. So as you come on, you can probably share the live so that other people can benefit. I know I advertised 9, but here we are. All right, so let's go. So the first thing you want to look at, let's go. So this question says, functions. I think functions is a favorite for many students. It's because it's very simple. So let's see. The question says, two functions are defined as follows. And we have g of x is equal to 4x plus 3, and f of x is equal to 2x plus 7, all divided by x plus 1. And the first one, it says, state the value of x for which f of x is undefined. So I have some of my students here. They're on the live as well. They're on with me. So anybody, let me just throw it out to you. State the value of f of x for which f of x is defined. Can anybody remember when f of x would be undefined?
Sir, when the determinant is 0.
Determinant, you sure? The determinant is the word
No,
looking for?
sorry, not the determinant, the denominator.
Denominator, excellent. When the denominator is equal to 0, that is when it is undefined. Excellent, excellent, lovely. So the fourth one. So we have f of x is equal to 2x plus 7, all divided by x plus 1. And the reason said it's undefined when the denominator is equal to 0. So the reason, how can we find when the denominator is equal to 0? What can we do to the denominator part of the function?
Sir, we solve for x.
Solve x and we equate it to what?
0.
Equate to 0 since we want to find when it's equal to 0. So this will be x plus 1 is equal to 0. And then we, solve for x. So x will be equal to, this is, the 1 is added. We take the subtract to 0, subtract 1 will be negative 1. So the value of x for which f of x is undefined is x is equal to negative 1. All right, and that goes for 1 month. And this goes for any fractional function. If you want to find when f of x is undefined, it must be equal to 0. A function is undefined when you have it in this form. Let's say 2 over 0, this is undefined because the denominator is equal to 0. So to find when this is undefined, we have to equate it to 0 and solve x. And I'll give you the value of x for which f of x is undefined. Well done. Well done, Darius. So next one, calculate the value of g of f of 5. The g of f of 5. This is a tight one. So we have a composite function there. We have a composite function. So what we need to do, we need to take f of 5 and we put it inside the g function. All right, so when you have composite functions, for example, g f of 5, you're taking a function f of 5 and you're putting it inside the g function. So a nice thing to do is to find what is the value of f of 5, and then you take that value and you're putting it inside the g function. All right, so we can find for f of 5, f of 5. All right, so we can find for f of 5. So f of 5 would be, you're putting 5 inside of the f function. So this would be 2x, instead of x, will be 2 times 5 plus 7, all divided by x plus 1. And we know x is 5. So 5 plus 1. So 2 5s, 10, 10 plus 7, all divided by 5 plus 1 is 6. So 10 plus 7 would be 17 over 6. So this question is going for 3 marks. So 17 over 6. So we got to find GF of 17 over 6, G of 17 over 6, because f of 5 is equal to 17 over 6. So this will be G of 17 over 6 is equal to, so we taking that and we put it inside of this function now. This will be 4x, instead of x, it will be 4 times 17 over 6 plus 3. And 4 times 17 over 6 will give us what? So 4 times 17 will give us 68. So 68 over 6 plus 3. That would give us 14, 1 and 1 over 3. So GF of, this question look kind of, this here looks, I wonder if did I make a mistake? Did I make a mistake, or CSEC gave us this fancy answer? But you never know. We did everything correct. So the first thing we had to do was find f of 5. So we found f of 5 to be 2 times x plus 7. So 2 times 5, which is 10 plus 7 is 17. And 5 plus 1 is 6. So 10 plus 7 would be 17 divided by 6. So that is f of 5. And then we take f of 5 and we put it inside the g function. And this is the g function. So this will be 4 times x plus 3. And we found x to be 17 over 6. So this will be 4 times 17 over 6 plus 3. Yeah, that is what we did, right? So our answer is 14 and 1 over 3. And the question went for 3 marks. I guess that is why. What do you got that?
Yes, sir.
Yes, sir.
All right, so those you know joining, I have a few of my students in class here with me because we'll be going for a long time, and it will be very, I was uncomfortable. It will be very strange talking to myself for a very long time. So I had to get some company. I had to get some of my willing students to come and join. Very brave. All right, so now went for 3 marks. So we had to do some amount of work there. You find for composite functions, you're taking the outer function and put it inside the inner function. So in this case, we had to find g f of 5. So we first find f of 5, and then we take that value for f of 5 and we put it inside the g function. All right, so that's it for that one. So last but not least, for 3 marks as well. Now, from the time you see a question is going for 3 marks, that means you gotta do some amount of work, right? CXC will not give away 3 marks like that. So you can't see a question for 3 marks and then do 1 line or 2 line. That means you're doing something wrong if you do 1 line or 2 line for 3 marks. Right? So the marks, direct correlation between the marks and the amount of work that you gotta do. 1 mark, very simple. 2 marks, yeah, a bit challenging. All right? 3 marks, you gotta do some amount of work. So F inverse of X. So you want to find F inverse of X. So we're dealing with the f of x function, which is so let me write back the f of x function. 2x plus 7 all divided by x plus 1. So anybody, f inverse of x. So let me see who can remember how to solve this here. How to work out this. Anybody?
Sir, we
All right, good. Go ahead.
we change the f inverse of x into y, and then we switch the y and x values, and then we work from there.
All right, excellent. So we change the f of x to y. So when you find the inverse of a function, it basically follows some steps. First thing, you change the f of x to y. So we'll have y is equal to 2x plus 7 all divided by x plus 1. And then what do we do next?
Change
Somebody
fx to y, sir.
change the x and the y, right? So we have wherever you see y, you put x. Wherever you see x, you put y. So this will be x is equal to 2y plus 7 all divided by y plus 1. So now, after we finish doing the nice part, we gotta make y the subject now. And this is where the challenge will come in. So let's go make y the subject. So anybody, what's the first thing we should do? Let me not work it out. Let me give you an opportunity to shine. What's the first thing
So
you
you
think we should
carry,
do?
so you carry over y plus 1, sir.
Carry over y plus 1. So the y plus 1 is divided. So we take over that y plus 1, it will multiply, right? So we'll have x multiplied by y plus 1 is equal to 2y plus 7. And then we multiply. We do use the distributive law. We should be able to do the distributive law in our sleep, given that the exam is a few months away. So, well, not a few months. Did I say months? Few weeks away. So this would be x times y would be xy plus x times 1 would be x. And that is equal to 2y plus 7. Good. What next? What else can we do to make y the subject? Anybody? What else can we do to make y the subject? Yeah, xy plus x is equal to 2y plus 7.
Sir, take over the 2y and the x.
Take over the 2y and the x. Right? So take over the 2y and the x. So we put all the terms with y, we put them together, right? So we'll have xy, and this is plus 2y. So we take over, become minus 2y is equal to, and we can carry over this plus x. So this will be 7 minus x. So we have xy and we have 2y. We got 2y, but how can we turn these 2y's that we have here into 1y? We cannot make 2y the subject. We have a y here and we have another y here. We can't deal with them 2y's. You gotta turn that into 1y. So what can we do? What thing in mathematics can we do to make those 2y's into 1y? Anybody?
Sir, we factorize.
Yeah. We factor out the y, right? We factor out the y from the two terms. So We have y here, we have y here, so we factor out the y. So we factor out the y, we will be left with x minus 2 is equal to 7 minus x. So now we can make y the subject by taking over this x minus 2. So this will be y is equal to this x minus 2 is multiplying the y. So we take the will divide. So we'll have 7 minus x all divided by x minus 2. And then the last but not least, the easy step, we change y to f inverse of x. And that's what we wanted to find. So f inverse of x is equal to 7 minus x all divided by x minus 2. And there you have it, your 3 marks. All right, 3 marks. All right, so as I said, there's a direct correlation between the amount of marks that the question is worth and the amount of work that you got to put into the question. So you want to keep that at the back of your mind when you're working on these questions. If you see a question for 3, 4 marks, you can't get 2 lines. You can't get 1 line. Unless CX, unless, CX decides to be real timed and, All right, everybody go there?
Yes, sir.
Yes, sir.
Yeah, for those of you now joining, I have a few of my students on the live because we'll be going for a while and I don't want to speak to myself for so long. I have some of my brave students here joining me, working out some questions with me as well. All right, so that was functions. This is probably one of the challenging ones for functions. Sometimes you may come across a simple function like f of, let me not use f, let me use g of x is equal to, let's say 5x minus 3, and I want you to find g inverse of x. This is a bit easier than the one that we just did. We follow the same steps, but it will be easier. So step 1, we change g of x to y. So we'll have y is equal to 5x minus 3. And then we interchange the x and the y. So we'll have x is equal to 5y minus 3. And then just like just now, we make y the subject. But this is a bit more easier to make y the subject. So we'll have x, the 3 is minus in, we take over the add. So x plus 3 is equal to 5y. And the 5 is multiplying the y. We take it over to divide. So x plus 3 all divided by 5 is equal to y. And then last but not least, we change y to g inverse of x in this case. So we can switch it around. So this will be, y is equal to x plus 3 all divided by 5. So we'll have g inverse of x is equal to x plus 3 all divided by 5. This is an easier version of this one that they can bring, and this will probably be worth 2 marks or so. So this is an easier version of this here. So if you come across one with a fractional function, you gotta put in some work. Right? You gotta do some factorizing some part of the other. And then from here, they can also ask you to find g inverse of, let's say 7, g inverse of 7. So you're taking this 7 and you're putting it inside of the inverse function that you found here. So this will be g inverse of 7 will be equal to, we put in 7 inside of this function. This will be x plus 3 all divided by 5. So instead of x, can we replace x with the 7? We got to do the same thing. So this will be 7 plus 3 all divided by 5. And 7 plus 3 is 10 divided by 5 is equal to 2. That is how you can find g inverse of whatever thing they want you to find. All right. Good. All right, so that's it for that part of functions. Let me see what else I have here. Oh. So I have another set of functions. So we have the functions f of x and g of x are defined as f of x is equal to 5x minus 4 all divided by 3, g of x is equal to x squared minus 1. So they want to evaluate f of 7. So f of 7 is simple. So let me work with that one. So we want to find f of 7. So once again, we put in the 7 inside the function f. So f of 7 would be equal to, instead of 5 times x, it would be 5 times 7 minus 4 all divided by 3. And 5 times 7 would be what? 5 sevens. Young brains. 5 sevens.
35.
35. See, I brain young and my own. All right, it is 5 to 35 minus 4 all divided by 3. 35 minus 4 should give me what? 35 minus 4 would give me 31. Correct, 31. 31 divided by 3. 31 divided by 3. We can break this down. So 3 can go into 31 10 times, and we'll have back with 1 over 3. So f of 7 is equal to 1 over 3. 10 and 1 over 3. All right? That was simple, right? 1 mark. 1 mark for that. So the next one, write an expression in terms of x for f inverse of x. So you want to find f inverse of x. And since we did this one just now, let me hear somebody somebody work this one out for me. So let me hear f inverse of x. So somebody work that one out for me. Take us through. Lead the way. Take over the class. F inverse of x. This is the function we're using, right? Anybody? Did everybody gonna leave me? All right, so we basically finding the inverse function, right? So that's when it's write an expression in terms of x for f inverse of x, we're basically finding the inverse function. You're not doing anything fancy. So somebody find the inverse function for me. All right, so it worked out. So we have to find, if we do like what we did just now, this is the function that we're using. So once again, firstly we replace what's the fourth step?
Replace f inverse with y.
All right, replace f of x with y, right? F of x with y, so we'll have y is equal to 5x minus 4 all divided by 3. And what next?
So
Next step.
change.
Yeah. Go ahead, sing.
So
Finish it, sing.
x equals 5.
All right, so we interchange x and y. So this will be x is equal to 5, y minus 4, all divided by 3. And then we simply make y the subject, right? All right, so I have to bring this down. So we simply make y the subject now. So this would be 3 is divided, we take the over multiplies, we'll have 3 times x will be 3x is equal to 5y minus 4. And then we make y the subject from here. So this will be this 4 is subtracting. Take the over add, so we'll have 3x plus 4 is equal to 5y. And the 5 is multiplying the y. So when we take that over, it will divide. So we'll have 3x plus 4 all divided by 5 is equal to y. And last but not least, we replace the y with the f inverse. It's f inverse of x. So f inverse of x is equal to 3x plus 4 all divided by 3. And that is how you write an expression in terms of x for f inverse of x. It's simple, it's just another way of the question is just in another way of saying find the inverse of f of x. All right. So look out for questions like that. They may tell you write an expression in terms of x for whatever, but it's simply finding whatever they give you here, right? F inverse of x. And the same thing here. Write an expression in terms of x for fg of x, right? So fg of x, what are we doing exactly for fg of x? This is a composite function. What are we putting here? Anybody, what are we putting?
Put in G into F,
So we
sir.
put in G times X into F.
We put in the function g into the function f, right? The one on the outside, we put in it on the one on the inside, right? We put in g of x into f, right? So, let me, all right, so let me pull this down a bit so I can work so we can see the equation that we're working. So we put this down on the bottom here. Number one, number two. Let's go, number three. So we put in the function g into f. So we take g, so f g of x is equal to, we taking the function g, we taking this function, and we putting it inside of this function. And how are we putting it? We're simply, how are we putting? We're simply putting the function, and wherever it's the x, you replace it and put in this function. All right, so this will be 5 times x, 5x, but instead of x, we're putting the function x squared minus 1. So 5 times x squared minus 1 minus 4, all divided by 3. And then we do some simplification. This will be 5 times x squared, 5 times 1. So 5 times x squared is 5x squared minus 5 times 1 would be 5 minus 4, all divided by 3. And then this would be 5x squared minus negative 5 minus 4, that would be negative 9. And we got to be careful with this. Some students tend to make the mistake of minusing 5 times 4. But remember, you got to take into consideration the sign in front of the term, right? The sign in front of the term, that is the sign that is governing the term. All right, so this is like I have negative 5 minus 4, and then all divided by 3. And that will be fg of x is equal to that. So that is how you write an expression in terms of x for fg of x. Everybody go there?
Yes, sir.
All right, so we're going into a big question. Let me see who can remember this one. So express the quadratic function gx squared plus 6x minus 2 in the form a plus h squared plus k, where a, h, and k are constant, 3 marks. I don't want to give it. I want somebody to tell me this here, man. Let's see who would have gotten these 3 marks. Would have gotten these 3 marks. So let me write it over. What kind of function is this again? What kind of function is this is? Anybody, what kind of function did they say it is? 3x squared plus
Quadratic
6x.
function.
It's a quadratic function, right? It's a quadratic function. So we want to write this quadratic function in this form. So let me hear what I think we should do first. Yeah, big question. Big marks.
So I think we have to find for key and each.
Yeah, fine for K and
Each, sir.
yes. So there are 2 ways we can do this, right? We can either complete the square or we can use the formula. So yeah, I can remember the formula.
Yes, sir.
Anybody remember? Yeah, you can remember the formula.
Yes,
We can
sir.
complete this. Yeah. So the thing is, first of all, what is A?
3, sir.
A is 3, right? So this here, so A is 3. What about H? What is H? How do we find H? First of all, before then, let me identify what is B as well. And what is C?
6.
B
B
is
is
6
6 and 3. C is -2, sir.
C is -2. Good. So we know A, B, and C. Now we want to find H and K, right? So how do we find H?
B over 2A.
B over 2A. All right. So it's B over 2A. So we know B is 6 over 2 times A, which is 3. So 6 divided by 2 times 3 is 6. So 6 divided by 6 is 1. So H is 1, right? Next thing, how do we find K again?
Sir, 4AC minus B squared divided by 4A.
4AC minus B squared divided by
4A.
4A. Like this here, exactly like this.
Yes, sir.
All right. Yeah, another form we could use as well. But nevertheless, let's go. So it's 4. So we just substitute the value of A, B, and C. So it's 4 times. So it's 4 times A, which is 3, times C, which is -2, subtract B squared, which is 6 squared, all divided by 4 times A, which is 3. So this is a lengthy formula. Can anybody remember the other formula? I mean, it's similar to this. It's the same thing, but
There's C minus B squared divided by 4A.
C minus B squared divided by 4A, right? Yeah, this is another formula you can use. They both are the same thing, but it's just that with this formula, what they did, they kind of simplified. They put 4A as the LCM, and 4A, 1 divided by 4A is 4A. 4A times C will be 4AC minus 4A divided by 4A is 1. 1 times B squared will be B squared. So it's the same formula, right? But whichever one you feel comfortable with, it's up to you. We'll get the same answer. Anyway, so let's simplify. So it's 4 times 3 times -2. 4 3 is 12. 12 times -2 would be -24, minus 6 squared would be 6 times 6 would be 36, all divided by 4 times 3, which is 12. Somebody said the answer is -5. All right, let's see. So -24 minus 36.
-6.
-60. -60 divided by 12.
Negative.
-5.
-5. So K is equal to -5. So we got a value for K, we got a value for H, and we got a value for A. Now it's just a simple way of putting that into this general form, which is A, open bracket, X plus H squared plus K. So it's just simple to put in those things, right? So we know the value of A is 3. This would be 3, open bracket. We're not changing X. X is X. So this would be X. H is 1. So X plus 1 squared. And plus K, which is -5. So plus -5. And we know these two signs will cancel out and give you a plus and a minus will cancel. So just give you a minus. So -5. And this is our answer in that form. All right, so it's just a matter of remembering. I'm not a big fan of remembering formula. That is what, for completing the squares, it's better if you remember the formula. So write it down somewhere, commit it to memory. Because I don't think this will be given in your exam. All right, so everybody go there.
Yes, sir.
All right. The last but not least, the other question says, hence or otherwise, calculate the value, state the minimum value of the function. State the minimum value of the function f of x is equal to 3x squared plus 6x minus 2. State the minimum value of this function. So we already have the function in the form, complete in the square form. So how can we find the minimum value? Anybody, how can we find the minimum value? Anybody remember?
So the minimum value would be k, which would be -5.
-5. So the minimum value would be k, which is -5, right? So this would be y is equal to -5. That is the minimum value. Minimum value means when you have a quadratic function, so we know a is positive, so that means the quadratic will come something like this. So the minimum value is basically telling you the lowest part on the graph. So this is the y-axis, this is the x-axis. So the minimum value is telling you the lowest part on the quadratic. So, and that is why we have y is equal to -5. That is the lowest part on the graph, right? Which is -5. Right? So that is how we have y equal -5. Everybody go there?
Yes, sir.
Let me see. Let me
Yes,
check
sir.
out the Facebook. Let me check out the Facebook comments. Somebody saying R is equal. All right. Anyways, so that is it for that one. Those questions can be challenging, right? When you have to write it in this form, it could be challenging. I know when I was in school, I was afraid of these kind of questions, right? But you shouldn't be afraid. Very simple, right? It's very simple. All right, so that was it for that one. So we coming out from functions and quadratic functions, and we heading into some bearings. How good y'all go to bearings? Everybody solid with bearings? All right, let's go. So I've been talking all the time. So let me get somebody to read the instructions here. My throat is working. Those who know joining, I have a few of my students on the live, so they will be working it along with me. Because it will be a lengthy live and it'll be very challenging to do it by myself. So I have my students here to keep me at it. Anyway, so yeah, somebody read it for me.
I'll go, sir.
Yeah, go ahead.
The diagram below, not drawn to scale, shows the relative positions of three reservoirs, B, F, and G, all on a level ground. The distance BF equals 32 km, FG equals 55 km. The angle BFG is 103 degrees, and F is on the bearing of 0.42 degrees from B.
Excellent. All right, thank you very much. Good. So it's basically explaining. I want to read these kind of instructions carefully, read it twice, and understand what is going on in the diagram. A big misconception that many students make is to just browse through the instruction. The instructions, they are not there to, as decoration on the page, right? They're actually there to guide you to get your answer. And, any question that CXC said, they will not leave you to make any assumptions. Any assumptions that you got to make wouldn't be assumptions, would be things that are proven. So you should not be looking at that and say, oh, this angle here look like this here. All right, so this got to be, this angle look like 32, so it'll be 32. All right, no, they will tell you everything that is going on in the diagram. Anyway, so determine the bearing of B from F. So we want to determine the bearing of B, which is here, from the point F. So from this point. Anybody could tell me, what is the important thing when you're dealing with bearings? What's the first thing you want to do when you want to take a bearing of an object? What line is important?
The north.
The north line, right? The first thing I gotta do is get the north line. Excellent. So we gotta draw the north line from F. Draw the north line from F. And then we want to take the bearing from here. We go all the way around to B, which is here. All right, so how can we find that bearing? Can we use what mathematical relationships can we use to help us to find that bearing? Oh, you go clockwise all the time, right? Clockwise. What mathematical relation can we do to find that bearing? Nobody could remember?
Sir, yeah, I think
Mhm.
so. We find for F by minusing 142 from 180. We find for F.
4 2 for 180. Why 4 2 for 180? You're correct. Excellent. That will give us this piece here, right? What is the relation between those two? There are two yeah, go ahead.
Sir, because it's a current year angle and current year angle is equal to 180 degrees.
Yeah, they're supplementary, right? So it's 180 subtract 42 degrees. 180 subtract 42 would give us what?
138.
138 degrees. 138 is from here to here. And we know from here to here is 103. So what else can we do to find from here to here?
So 360 minus 138 plus 103.
So 360 minus 1 third. Why do you know it's 360 though? How do you know it's 360? Why am I using 360? You're correct, right? Anybody correct? Why do you minus 360 though?
Sir, because the circle is equal to 360 degrees.
Yeah, it's a circle is formed. They're right away wrong. Yeah, somebody's saying it because it's circle, right? So 138 plus 138 plus 103 would give us
241.
241 and 241 subtract 360. Give us a value of 119 degrees. So 119 degrees. 119 degrees. So the 119 degrees, that is from here to here. So the bearing, what would be the bearing? So we can say, so can we say the bearing of B from F would be what?
119 plus 103.
119 plus 103. That we want all the way around here, right? So 119 plus 103, and that will give us a value of
222.
222 degrees. All right. And this went for about, I think, 3 marks. So bearings, you start from the north line and you go all the way around to the line that you want to find, right? And the bearing of something from where you want to measure from, that is where the angle has to be. From something, you go all the way from, right? So the bearing of B from F, you got to start from F. All right, good. So that was number 1. Number 2, calculate the distance. So let me erase all this one. So calculate the distance BG, giving our answer to 1 decimal place. So you want to find BG, which would be this line here, right? To 1 decimal place. So what can we do there? What can we use? BG.
Sir, I could use the
The
cosine
cosine
rule.
rule.
Cosine rule. What's the cosine rule by? They will give you the cosine rule. What is the cosine rule?
Sir, a square is equal to b square plus c square minus 2bc cos a.
A square is equal to b square minus 2bc times cos a. Now this is the formula that they would give you in the exam, right? But we must understand what this formula is saying. Of course, you don't have B and A, B, and C, and so on. We have B, F, and G. So let's try to use the letters that we are given here to put in the formula. Create our own formula, substitute the letters that we're given. So we know this side is F, and we know this side is G, and this side is B. Say, what would be this, sorry, that angle here. So what would be this side here?
Common b.
B sir, common B.
Common B. And what would be this side here?
Common G.
Common g.
Common G.
And then
And what would be
last
this
is
side here?
common F.
Common F. So you want to find the side F, and we're given the angle F as well. So we can say, instead of a square, you can say F square is equal to, and the other two sides, which would be B square plus G squared minus 2, these two same letters, to BG multiplied by cos the angle cos F. Right? Whatever is the side here, you gotta get the corresponding angle to that. Now we can do some substitution. So we can have F squared is equal to B squared, which would be 55 squared plus G squared, which is 32 squared minus 2 times B, which is 55 multiplied by G, which is 32, multiplied by cos F, which is cos 103. And it's just a matter of doing some simplification. This will be F squared is equal to, so work with this piece for me. 55 squared plus 32 squared.
4049.
When you work with this entire thing?
Yes, sir.
All right, so 4039.
49.
49. All right. Minus, let's multiply 2 times 55 times 32. 2 times 55 times 32. What would that give us?
3520.
3,520 multiplied by cos 103. So let's multiply our answer by cos 103. So 3,520 multiplied by cos 103. And that should give us 4,049. Subtract. We multiply this piece here by cos 103. We should get negative 791.8. We all got that?
Yes,
Yes,
sir.
sir.
So it's equal to F squared. So F squared would be equal to, so the minus and the minus that would become plus. So we have 4,049 plus 791.8. How that give us? That should give us a value of 4,840.8. All right, and of course we're not done there. We don't want to find the value of F squared. We want to find the value of F. So we got to take over the square. So this will become F is equal to the square root of 4,840.4. The square root of that. So we take a square root of that, we'll get a value of
Sir,
69.5.
69.5.
69. You sure?
69.6.
Aye,
6, sir.
69.6.
Sorry.
So 69.6 km. Right? And that is the distance. So again, the thing is, they told us to find BG, right? I mean, we know F is BG. So let's just leave anything for granted. So we can say BG is equal to 69.6 km, right? And we leave that as our answer. Everybody go there? See what's going on in it. That. Yeah, so it's just a matter of substitution. Now the thing about the cosine rule, use the cosine rule when you're given two sides and an angle, right? And it depends on which two sides and which angle you're given. If the side that you want to find, in this case F, and you're given the corresponding angle to that, well, the opposite angle, and you're given the two sides here, then it's when you can use the cosine rule. We use the sine rule now when you're given similar things, but not in that order. All right. In order to use the cosine sine rule, you must be given 3 out of the 4 things. Because you want to find for one. Right? You must be given 3 out of 4 things. And in algebra and maths and so on, any formula that you're given, whatever are the values that you gotta substitute in the formula, you must be given only one thing must be missing from the formula, and you can find that one thing. It doesn't matter the order of the formula, as long as one part of the formula is missing, you can use that formula to find for it. Right? That is the key. You can't have 2 things missing and use the formula to find for those 2 things, unless the 2 things got the same value. But yeah, so that's what you gotta be on the lookout for. You must be given only one thing must be missing from the formula, any formula that you want to use. All right, so the next one, calculate to the nearest degree the bearing of G from B. The bearing of G from B. So the bearing of G, now this is a part that many students mix up. The bearing of G from B. So from B would be here. So we want to find this bearing. Many students would go and they would go and draw the north line here and then they go all the way around and so on. No. The bearing of G from B. All right? Keyword there is from. From is where you're measuring the angle from. So what can we do to find that bearing? So let me write in this side. This side is equal to 69.6
Sir,
km.
you can use the cosine rule again.
Use the cosine rule. You want to use the cosine rule? Any other easy rule you could use? I mean, you could. Any other rule?
Start a sign.
You can use the sine as well. Because we're given 3 sides and an angle, and we want to find. We're given all 3 sides of the triangle and an angle, and we want to find an angle. So we can use the sine rule, or you can use the cosine rule as well. But the cosine rule will be a bit longer, right? So the sine rule is shorter, easier. So let's use the sine rule. So you want to find angle B. So what is the cosine? What is the sine rule again? What is the sine rule? I can't remember. Yeah, help me out.
Sir, A divided by sine A is equal to B divided by sine B is equal to C divided by sine C.
Yeah. A divided by sine A. Sine A would be the angle, so that would be the big A. And B divided by sine B, angle again at the bottom, and C divided by sine C. All right? So, yeah. But of course, this is it in its general form. We can use the letters that we are given. So let me zoom out. So we want to find for angle B. So this will be B divided by sine B is equal to, we can use any pair, any combination, any pair of the equation. We can use these two, we can use these two, we can use these two, it doesn't matter. So B sine B is equal to let's see. Since we are given f, so we'll do f over sine f, right? Because we are given the angle f, and so the side f. Now this is the side f, and this is the angle f. So we got to use those two combinations. So B would be, let me zoom out. So B would be side B would be 55 over sine B would be the angle that we want to find. So sine B, which is this angle here. This angle we find, by the way. That is angle B. So F would be 69.6 divided by sine F, which is 103. And then we know, let me ask, what can we do here to help us to find for angle B? As you can see, we just have one unknown, right? So that is what you want to look for that is why you want to make sure you have one unknown alone. You can't use a formula when you have two unknowns. It must be one unknown only. So what can we do?
Sorry, cross multiply.
Yeah, we cross multiply. You cross multiply to help us find for B. So we cross multiply. So we can have 69.6 multiplied by sine B is equal to 55 multiplied by sine 103. And since we want to find for B, this 69, since it's multiplying, when we take it over to divide, so we'll have sine B is equal to 55 multiplied by sine 103, all divided by 69.6. And we use our calculators to simplify this. Use our calculators to simplify this. This will be 55 multiplied by sine 103. How did that give us? And then we divide by 69.6.
Sir, 53.6.
When we do everything, when we divide everything. Oh, that's when we work with the top. So divided by 69.6 now.
0 point. Sir, how many decimal please?
Let's use 4.
0.06.
You sure 0 point? 0 point?
0.06.
You sure?
Sir, 0.769. But then it can be 0.7.
All right, let's use 5 decimal, please. Let's use 5. 0.76.
0.76997.
You sure it'll be 7?
998.
Good. Excellent. Check this. Make sure your calculator is in degree, right? Make sure your calculator is in degree. If it's in radians, you will get some issues there. I heard somebody. God just know. So make sure your calculator is in degree. CSEC maths degree. Anyway, calculus and them things. Anyways, so degree, ensure your calculator is in degree, else you will get something different, right? So make sure before you go in your exam, make sure you take a pointer or your pencil and you click that reset button at the back. Because you don't want to lose marks because or you work your entire paper and then you check and you realize at the end you have 5 minutes remaining, you realize your calculator was in radians. It'll be a terrible situation to be in. So to find for B now, we say B is equal to, and we take over sine, it becomes sine inverse of 0.76998. So B would be equal to, I take sine inverse of this. So what do we get?
Or 50.35 or 4.
50.35. 50 point. All right, let's say 50. Did they say how many? Did they say round off to any degree? Nearest degree. So 50.35 to the nearest degree. 50.35 to the nearest degree is what?
50.4.
Aye, 50. Nearest degree, nearest whole number, it's 50. So 50 degrees. So B is equal to 50 degrees. So we know B is equal to 50 degrees. So what would be the bearing of G from B? Let me zoom
So
out.
the bearing G
92,
from
sir.
B will be 50 plus 42. Is how much?
92.
So we gotta add these two, right? Add the 42 and the 50. It'll be 50 plus 42 will be 92 degrees. All right, 92 degrees. Easy marks, right? Let me see what's going on. This is on Parsons commenting. Yes. AC Clark, Nicola, Bell. Yes. Emmanuel Hills. All right. So that was a bearings. That was bearings, right? Everybody go there? So as you come in, you can share the live and tag a CXC student. So I watch a save been live for 1 hour. Is that so? It's been 1 hour already, students? Has it been 1 hour? Or y'all didn't check in? Anybody check in? It's been 1 hour? Yeah, it's been 1 hour. Oh my. It didn't even
Yes,
seem
sir.
like 1 hour. Feel like 5 minutes, right? Felt like 5 minutes to anybody? Yes, Casey Clark. It felt like 5 minutes, man, or just me alone. Oh, probably just me alone. Anyways, the next one. The circle shown below has center O. The points A, B, C, and D lying on the circumference has center O, and the points A, B, and C lying on the circumference. Straight line passes through points A and B. Angle CBD is equal to 49, and angle OAB is equal to 37 degrees. So the first one, write down the mathematical names of the straight line BC and OA. So what are the mathematical name given to BC? Anybody? BC. This is mathematical name given to BC. BC would be here. Let's see if anybody will get it in the chat or I will get it here for us. We're also live on YouTube. Let me see what's going on over on YouTube. Oh, yeah, forces on YouTube as well. Somebody's saying they're listening. Yeah, anybody? Yeah, go ahead.
Sir, so it's a chord, sir?
It's a chord. Yeah, it's a chord. It's a chord. So BC is a chord. BC is a chord. And what is OA?
Radius.
Radius.
Radius. Two easy marks here. Yeah, so BC is a chord, OA is a radius. Two easy marks. Let me see. What got it? Yeah. So next one, determine the value of each of the following angles, show detailed workings where necessary, and give a reason to support our answer. So we want to find the value of angle X. So we have angle X, which is this angle here. So let me angle X. Anybody, what's the value of X and how can we find that value? So let me zoom up.
Sir, so we know that is an isosceles triangle.
An isosceles, how do you know that?
Third, because they end up at the point in the middle
Mm-hmm.
and it touches the end of the circles.
Right. Yeah, so it's an isosceles triangle, meaning these two lines are equal, and also in addition to those two lines being equal, what else do we know again? If here is 37, here would be what?
37, sir.
37, excellent. So if there is 37, there is 37. So we can say x would be equal to 180 subtract 37 plus 37. It will be 180 subtract 37, 37.
74.
74, sir.
74. And 180 minus 74 give you 106. So we can say, what will our reason be? What will our reason be? All right. What would the reason be? So you can say because it's an isosceles triangle, right? So you can say O. So you can say ABO is an isosceles triangle. All right, that would be a reason. It's an isosceles triangle, meaning the two angles are equal, and so on. All right. So that's it for that one. All right. So the next one, calculate. Well, we got to find the value of y. So we know here's 106. What would be the value of y? It's nice and easy.
37.
37. Why? Careful. Don't assume, right? Why? What would be the value of y? We know it's a triangle and it's at a certain location. Let me outline the triangle for you. Somebody saying in the chat 37 because as Z, I guess you're talking about Z angle. All right. We have a Z. In order for you to have a Z angle, you must have two parallel lines, right? And I don't think in the instruction I read anything about two parallel lines. Did I missed it? No. No, they didn't say anything about parallel lines. So it can be Z because you don't have a parallel line. Now look at it good. Look at the triangle good. Where is that triangle located?
Sir, in a semicircle.
In a semicircle. Excellent. So it's located in a semicircle. So it's located in a semicircle. So how can that help us to find for y?
Sir, it'll form a right angle.
So we know here would be a right angle. All right. So here would be a right angle. So we know two angles. We know this angle here and we know this angle. So now we can find for y simply by subtracting. So you can say y is equal to 180 subtract 180 subtract 49 plus 49 plus 90, right? So this will be 180 subtract 49 plus 90.
139.
139. This will be 180 subtract 139 will give us a value of
41.
41 degrees. And our reason would be angle in the semicircle is a right angle or 90 degrees? All right, the angle in a semicircle is a right angle. Yes, Casey Clark. And that is why. All right, everybody go there? So we use some circle theorem and we use some knowledge of triangles to answer this question. All right, so sometimes you will have to do a mixture of the two. You got to know about your triangles, type of triangles. You have to know about angles. Sometimes you'll have a Z angle. Sometimes you will have an interior angle, and sometimes you'll have to use theorems, right? Or sometimes, you can use any one. All right, so you're not limited to just the circle theorems. All right, you're not just limited to the circle theorems. It could be any combination of any theorems or anything that you know that can help you. All right. So that is that. So let's see what else we have here. So we move into some matrices now. And we are all good. They are good with matrices. Is my friend Lino there?
Yes, sir.
Lino, all right. All right. Lino should be leading here with matrices. He knows why. Anyways, so let's go. Matrix A, B, and C are such that A is equal to 3, 2, 5, 4, and B is equal to 4, 0, 3, -1. To show why multiplying A and B, that AB is not equal to BC. So this is telling you that they want to multiply AB and they want you to multiply BC. And after you finish multiplying, those two matrices should not be equal. All right? They want you to show by multiplying A and B that AB is not equal to BC. So the first thing you gotta do, you gotta find for AB and then you find for BA. Can anybody remember how we can multiply matrices?
Row by column, sir.
Row by column, right? Row by column. So let's multiply the rows by column. So let me see if I can work it. All right, let me write out the matrix. So we have matrix A is equal to 3, 2, 5, 4. And matrix B is equal to 4, 0, 3, -1. Yes, Casey Clark. Row by column. So let me drag this down, put this at the bottom. So let's find for AB. So we want to find for AB and BC. So let's find for AB first. So AB is equal to 3, 2, 5, 4 multiplied by 4, 0, 3, -1. So row by column. So it's row by column. So row by column would be somebody help me out.
Sir, it'll be 3 times 4 plus 2 times 3.
2 times 3. Good, that would be for the first one. And then we go row by column for the second one now. Would be
3 times 0 plus 2 times -1.
good. And that's for the first one. That will be this row by this column.
5 times 4 plus 4 times 3.
And last but not least, these two.
5 times 0 plus 4 times -1.
Good. So let me ask this now. This part here can be a bit confusing for persons. What is a good indication to check for when you're multiplying? To know that you're correct. What is one thing you can look for? A trick or you can look when you finish setting up this part here. What is one thing you can look for?
Sir, the last number in both rows should be equal.
So these two them should be the same, right? So there's one thing you could check for. So if those are not the same, that means you did something incorrect, I want to go and, check back to see where you made the error or the mistake. All right. So be on the lookout for that, because, it can get a bit confusing when you're at this piece, especially after matrices would be the last of the things on the paper. You're tired from the exam. So be on the lookout for that. So that would be that. So then we just do some simple computation. So this would be 3 times 4 would be 12 plus 2 times 3 would be 6. 5 times 4 would be 20 plus 4 times 3 would be 12. And 3 times 0 would be 0 plus 2 times negative 1 would be negative 2. 5 times 0 would be 0 plus 4 times negative 1 would be negative 4. All right, so now we have 12 plus 6 would be 18. 0 plus negative 2 would be negative 2. 20 plus 12 would be 32. And 0 plus 4 would be 0 plus negative 4 would be negative 4. So that is our answer for AB. All right, so the question said to show that AB, show by multiplying AB and BC are not the same. So the next thing we got to do, we got to find for BC. All right, so BC would be 4, 0, 3, negative 1. And then we do anything reverse, 3, 2, 5, 4. So we do the same thing like what we did, row by column. So this would be row by column, row by column. So this would be 4 times 3 plus 0 times 5. And then this would be 4 times this here, by this here now. 4 times 2 plus 0 times 4. And then we go this here, by this here now. And this will be 3 times 3 plus negative 1 times 5. And then the same thing, this here by this now. And then this will be 3 times 2 plus negative 1 times 4. And once again, you want to check to see if, these two are corresponding. If those two are not corresponding, it means you made some error. All right, so row by column. And then we do some simple computation. It would be 4 times 3 would be 12, plus 0 times 5 would be 0. 4 times 2 would be 8, plus 0 times 4 would be 0. And 3 times 3 would be 9, plus negative 1 times 5 would be negative 5. And 3 times 2 would be 6, plus negative 1 times 4 would be negative 4. All right. And then we simplify. 12 plus 0 would be 12. 8 plus 0 would be 8. 9 plus negative 5. Let me throw this out. 9 plus negative 5.
Positive 4.
Positive 4. At least 2 would point into a negative. 9 minus 4 would be 9 minus 5 would be 4. 6 plus negative 4. 6 plus negative 4.
Positive 2.
Positive 2. Excellent. So this would be BC. So we can clearly see that AB and BC, they're not equal, right? So that is what the question asks us to show. So we can clearly see that those two are definitely not equal.
Sir, is BA, sir.
Oh, BA.
Sir, it's BA, sir.
So BA instead of BC, right? BA. Yeah. All right. So unlike matrices, if you have two normal numbers, if you got 2 times 3 is 6, 3 times 2 will also be 6. So this doesn't hold for matrices, right? The order of the multiplication, it matters. All right, so that's what they wanted you to show. So the next, they want us to find the inverse of matrix A. The inverse of matrix A. So you have matrix A here, and they want you to find the inverse of that matrix. Inverse of matrix A. So let me work that right here. Anybody can remember how we find the inverse of a matrix?
There are 1 divided by the determinant times the adjoint.
1 divided by the determinant multiplied by the adjoint. So 1 divided by the determinant multiplied by the adjoint. So we can find the determinant separately and the adjoint separately. So let's find the determinant of A for us. So the determinant of A would be, can you remember the formula to find determinant?
AD minus BC.
AD minus BC. So we're using matrix A, right? So we know the first element is A, the second element is B, this is A, this is B, this is C, this is D, right? So A, B, C, D, right? It's A times D. So we know A is 3 times D, which is 4. Subtract B times C, which is 2 multiplied by C, which is 5. So 3 4s, 12, minus 2 5s, 10. So the determinant of A will be 12 minus 10 would be 2. So the determinant of A would be 2. All right. Next, we want to find the adjoint. The adjoint is a nice thing to find. So you want to find the adjoint of, all right, let me write back this thing here. So matrix is 3, 2, 5, 4. You want to find the adjoint of this. So the adjoint, how can we find the adjoint again? It's a nice thing.
D negative B negative CA.
A lot of fancy. All right, so we switch these two, right? We switch these two. We interchange those two. We interchange the 3 and the 4. So where is the 3, we put 4. And where is the 4, we put 3. And then we flip the signs of these two. So this will be -2, -5. That is the adjoint. You switch and you flip. You switch these two and you flip the sign. So if this was a negative, return to positive. So that's the adjoint of A. So we have the adjoint of A and we have the determinant of A. So next is 1 over the determinant times the adjoint. So let me work this right in the corner here. So A inverse would be 1 over the determinant times the adjoint. So it will be 1 over the determinant, which is 2, multiplied by the adjoint, which is 4, -2, -5, and 3. So we multiply, we do some scalar multiplication, meaning, the thing directly outside, you multiply it by all the elements in the matrix. So this would be half times 4 would be 4 over 2. Half times -2 would be -2 over 2. Half times -5 would be -5 over 2. Half times 3 would be 3 over 2. And then we just simply, simplify it. Simply simplify it. Anyway, so we simplify it. So it'll be 4 divided by 2 would be 2. -2 divided by 2 would be -1. -5 divided by 2 would be -2.5. And 3 divided by 2 would be 1.5. All right, and that is it for that. That is it for the inverse of that matrix. It's 1 over the determinant times the adjoint. And that is how you can gain your full marks for that question. And as you can see, this question went for 2 marks. Everybody go there?
Yes, sir.
Yes, sir.
All right, so for those who
Sir.
now joining, normally I would go live by myself, but today I have a few students joining me. They said they were willing and excited as I am to come and work some mathematics and help everybody prepare for the exams. All right, so that's what we're doing. I have some students allowed myself. We going through them together. All right. So these are some random questions that we took, random past paper questions that we are working. Try to mix and match as many concepts as possible, to see how this can help students in their exam. All right, so the next one, Write down 2 by 2 matrix representing the matrix product A times. Write down the 2 by 2 matrix represent the matrix product A times A inverse. Anybody? Two by two matrix representing that. Anybody could tell me what this is asking us to find?
So is it the identity matrix? Huh?
Yeah, yeah. Yeah, they're asking to find the identity matrix, the 2 by 2 identity matrix. Anybody? What's the identity 2 by 2
So
matrix?
1 0 0 1.
Sure? All right, so should be 1 0 0 1, right? As I said, also. Yeah. So
Yes,
1
sir.
0 0 1. Good. Next one. Write the following pair of simultaneous. Write the following pair of simultaneous equation as a matrix equation. So we have the simultaneous equation 3x plus 2y is equal to 1. 5x plus 4y is equal to 5. So let me drag this down and put this at the bottom. All right, so I got to put some space. All right, so let me. So let's go. So you want to write this in a matrix form. What would that be? Very simple. They want us to write the following pairs of simultaneous equation as a matrix equation. What would this be? Fairly simple. Let me
Sir,
help Miss. Go ahead.
sir, in the first one you'll get 3, 2, 5, 4.
All right, pause. 3, 2, 5, 4. So just taking the number, the coefficients of these, right? 3, 2, 5, 4.
And in the other bracket you'll get x and y
So you multiply by x and y, which would be the two variables.
is equal to 1 and 5.
1, 5. All right. Yeah. All right. Yeah. So yeah, see Casey Clarkson, and yeah, that's correct. So you take the coefficients, you put in one bracket, you multiply it by x and y, which would be two variables, and you equate it to the answer. And then it's just a matter of, well, did they say to solve it? Yeah. So that we had one mark to write it in the matrix form, and the next one they ask us to solve it. So write the solution of your matrix as a product of two matrices. So what we have to do, let's see if we get some space to work it out. So we have to solve for x and y. So by solving for x and y, we have to take this over the equal sign and put it with there. So when we take this matrix over this equal sign, what will happen?
It'll be inverse.
Yeah, the inverse, right? So when we take this matrix over, it will become the inverse of that matrix. So the inverse of that matrix, I think we found the inverse of that matrix early on. Let me see. Yes. Yes. You see, we found the inverse here. This one, the inverse of A. So that is one thing that CX do. They would bring whatever you found at the top to help you to solve for the one at the bottom. So you already found the inverse here. So let me copy that. We already found the inverse here. So this is the inverse. So there's no need to redo the entire thing, right? We already found the inverse. So this will become xy is equal to. Now, where do we put this? Where do we put the inverse? At the front or at the back? Do we put it in front here? Do we
In
say
front, sir.
in front? Let's see. Let's put it in front and see. So do you put it in front and say that multiplied by 1, sorry, 1, 5? Or do we put 1, 5 multiplied by that? This is a this
1/5
is
multiplied by the inverse of itself.
why though? Why the
So
1, 5?
because it's a 2 by 1 matrix and this is a 2 by 2.
So this is a 2 by 2 matrix, and this is what? This one is what?
A 2 by 1, sir.
This is a 2 by 1, 2 by 1. And good. How would that help us to determine where to put it? It has to be what? The two matrix got to be what for multiplication?
Compatible.
Yeah, they must be compatible. And how can you tell if two matrices are compatible?
When you put it together, the inner number should be equal.
So those
And
two
the
numbers got to be equal. Right? So those two numbers got to be equal. This got to be equal to this. And if we had set up the other way, it would have been a 2 by 1 multiplied by a 2 by 2. And a 2 by 1 multiplied by a 2 by 2, you see the inner numbers are not equal. That means they are not compatible for multiplication. All right, so they must be compatible for multiplication. That is why you put it in front and not at the back. All right, so the R in this case will matter how you put it. Because if you put it behind you, well, you work and you wonder why you're getting the answer and you get frustrated and so on. So they must be compatible. So you put it at the front. So we're running out of space. So let me see how I can create some space. Oh, what I'll do, we make this a bit smaller. Make it a bit smaller. And let me erase this part and make this a bit. Let me drag this up. Let me drag this up and put it there. All right, let me do some separation. Yeah. And now we multiply. So a next thing. So we have a 2 by 2 and we have a 2 by 1. Right? 2 rows, 1 column, right? That's how we get 2 by 1. 2 rows, 1, 2, and 1 column. That's why it's a 2 by 1 matrix. So we have a 2 by 2 matrix. We know these two matrices are compatible. But the next thing, a next problem that many students may reach up in, you want to know, okay, when you multiply a 2 by 2 and a 2 by 1, what would be the order of the matrix when you multiply them?
2 by 1.
2 by 1, how you got a 2 by 1? You're correct. How do you know it's 2 by 1?
Sir, because the outside values.
Yeah. So these two here, these two outside matrix will determine what would be the product of the two matrices. So it will be a 2 by 1. So they use this as a guide when you're multiplying. When you multiply two different order of matrix, the outer numbers will dictate what would be the order of the matrix. All right? So we'll have a 2 by 1 matrix as our answer. So let's work it out now. So this would be 2 row by column, 2 multiplied by 1 plus -1 multiplied by 5. This would be -2.5 multiplied by 1 plus 1.5 multiplied by 5. And then we work this out. We'll have 2 times 1 is 2 plus -1 times 5 would be -5. And -2.5 times 1 would be -2.5 plus 1.5 times 5.
7.5.
7.5. Good. So xy is equal to that. So xy would be 2 plus -7. 2 plus -5, sorry.
-3.
-3 and -2.5 plus 7.5 would give me
5. +5.
+5. So let me see. Did it say write your solution as a product of, yeah. But then again, the question said, write your solution as a product of two matrices. Did they say to solve it? Actually, they did not say to solve it, you know. But we went ahead and did some extra steps. They said to write it as a product of two matrices. Anyway, that's all. It doesn't matter. So yeah, this would be our answer. The question they really said to solve it. I guess we could have probably stopped at this step. Right? Could have probably stopped at this step and would have gotten all the marks based on what the instruction is doing. But yeah, to be on the safe side, you never are, we're dealing with, you never know what will come in this year paper. So this is how you solve it actually, right? So yeah. But you could have stopped here based on what the question asks. But yeah, this is how you go ahead and solve this. And you can put in your answer. You can say x is equal to -3 and y is equal to 5. You can say therefore x is equal to -3 and y is equal to 5 as our answer. What year paper? No, we have some random years put together. I just pulled some random questions across different topics. So there's no specific year. I for the person who asked that. All right, so everybody go there.
Yes, sir.
All right. We're running with the marathon, the maths marathon. Okay. You're running. Anybody running out of breath? Anybody blowing hard? Everybody's blowing hard. Everybody ready? Everybody solid?
Not really, sir.
Saying you're blowing hard. You need some water. Casey Clark is running strong. Really? All right, let me know. Somebody said they are all right. Somebody said they are hungry. How you come to run a marathon and you didn't eat, man? You want your blackout? You got people. There it is. All right, so let's see. All right, let's see a message wrong. All right. Casey Clark said it, and Casey Clark has been out with us since the beginning. Casey Clark is going strong. Excellent. So let's carry on. Remember it's a marathon, right? It's not 100 meter or a 200 meter. All right, so let's go. So let's see. Given the vectors OP is equal to 3, 4, and PQ is equal to negative. All right, Alexandra, Mia. PQ is equal to -1, 2, and RS is equal to 1, 3. Determine the vector OQ. OQ. So let's see. We got some vectors now. We move from matrices. Matrices have vectors and matrices, they go hand in hand. I think they comes under one topic in the syllabus, vectors and matrices. So you can't do matrices without some vectors. So let's see. Determine the vector OQ. 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 So what would that be? We got a vector OP and we got a vector PQ and we got a vector RS. Let's see who can remember. How can we find OQ? 2 marks. Anybody who's with me here? How can we find OQ? Ah. All right, let me help you out. Remember, OQ, you got to move from O to Q. So you got to find a vector. Find 2 vectors that will help you to move from O to Q. All right, so let's see. We can start off with OP. So we can say OQ is equal to OP. Move from O to P. And we add that. So we move from O to P. And then we can move from P to Q. Because we got to start with O and we got to end off with P. Then we can go from P to Q. From O to P, and then from P to Q. And that's how we can find that vector, right? The force and like, what can I say? Force left or the force point in the vector tells you where you start from, and the last point tells you where you end off. So you can start off with O. So we go O to P, And then from P, we go to P to Q. All right? These two letters got to correspond. Triangular. Anyways, so that's how you can find that. So you're not working a specific area for the course of that too. So from O to P, P to Q. So we know OP is equal to, they gave us OP to be equal to 3, 4. This will be 3, 4. Plus PQ, we found PQ to be -1, 2. This would be 3 plus -1, or 4 plus 2. Would be 3 plus -1 would be 3 plus -1 would be 2, and 4 plus 2 would be 6. As see Casey Clark saying in the chat on Facebook. All right, the folks with me here, got that?
Yes, sir.
Yes.
So that was a refresher, right? That was a refresher for everybody? Or it wasn't?
Yes, sir.
Okay.
Yes, sir.
So I trust that if you have been refreshed and it's now fresh in your head and it will stay there. All right. So yeah, the points, you use them as a guide. You start from O, you go from O to something, and then from that something to the last point in the vector that they ask you to find. All right. So from O to a point, and then from that point to the point that you want to stop at. All right, good. So show that OQ is parallel to RS. So you got OQ. So this is OQ. This is the vector OQ, and the vector RS would be 1, 3. So how can we show that those two vectors are parallel? How can we show that those two vectors are parallel? Look at them good and think about it. Parallel vectors. I can hear the books flipping. I can hear the pages flipping. Let me see if anybody in the chat can give me before somebody tells me in this
Sorry, I
class.
think we'll scalar multiple of
Aye, scalar multiple. So one vector must be a scalar multiple of the other. And do we have that in this case? OQ and RS?
yes, sir.
So which one is a scalar multiple of which? And what is the scalar? What is the scalar? We got 2, 6 and 1, 3. What is the scalar? What can we multiply by what to give you the other vector?
One RS.
RS is equal to? What can we multiply by RS to give you?
OQ.
Aye. Jamal Prince. Jamal Prince. Jamal, I wonder if you see him, Jamal. Jamal, why you not in this class? In the chat? All right, no problem, Jamal. As long as you're there. Yeah, so we can multiply RS by 2. So we can say OQ is equal to 2RS. OQ is equal to 2RS. And that's how you can tell if two vectors are parallel. One must be a scalar multiple of the other. All right, one must be the scalar multiple of the other. And that is how you can tell if they are scalar multiple of each other. And a scalar is just a number. And you multiply one vector by a number to give you the other vector. All right? And that's how you can tell if two vectors are parallel. All right, so one must be a scalar multiple of the other. And a scalar is just a number that you multiply by the other vector to get that. All right, so that is that. 1 mark, simple 1 mark, right? This is II. So let's go B. So B says X, Y, Z is a triangle. And M is the midpoint of XY. M is the midpoint of XY. XY is equal to A, YZ is equal to B. So let me draw the triangle first of all. So we got a triangle. Got a triangle. Let me draw the triangle. Good. So you got a triangle X, Y, Z. So we said that XY is equal to A and YZ is equal to B. So they want us now to express the following vectors in terms of A and B, simplifying their answers where possible. X, Z. So they also told us that M is the midpoint of XY. So XY, M would be here. Right? M is the
Sorry, it's
midpoint.
XZ, sir.
Pardon me?
XZ,
Oh,
midpoint of
XZ.
XZ.
All right, so that's what I got here. So XZ. So XZ would be the midpoint, there would be M, right? XZ. Good. So they want us to find XZ. So XZ or Z. XZ would be here from you're going in that direction. All right. So to move from X to Z, we see we can go across using the triangle. We complete the triangle. We go from X to Y and then from Y to Z. So XZ would be simply equal to XZ, as it says, one mark would simply be equal to, in terms of A and B, would simply be XY plus YZ, and XY we see is equal to A plus B. All right, that is XY, that is A plus, that is XZ, A plus B. Simply A plus B. And the last one, we want to find with 3 marks. 3 marks, remember I said about 3 marks earlier. MY. So you gotta move from M to Y. From M to Y. How can you find for M, Y? Where do you move from? From where to where? You move from where to where and then from where to where?
So we could move MX and then XY, or you could move the other way to MZ.
So yeah. So let's choose the easier part. So we can move from M to X and then we can go from X to Y. All right. So we can go from M to X, from X to Y. So the thing about MX, M is the midpoint of XY, right? Well, XZ. And we found XZ to be this at the bottom here, right? So if you want to find the midpoint of this, midpoint means halfway. What can we do to A plus B to get half of that? I mean, I kind of give you the answer in the wording. How can we find half? How can we find half of A plus B? Anybody, half of A plus, all right. It'd simply be half A plus B, right? Half A plus B
Divide,
plus, yeah, divide by 2. So you half of A plus B plus XY. And we know XY is simply A. So it says to simplify where possible, so we have to simplify this. So this would be half of A plus B. This half, I gotta multiply everything here. So this would be half times A would be A over 2 plus half times B would be B over 2 plus A. So we can put the A's together. This would be A over 2 plus A plus B over 2. So A over 2 plus A over 2 plus A. That's like half A plus A. Half A plus A. Yeah, so A over 2 plus A. There's like half. There's like
2A,
half
sir.
plus 2A, sure, man. Half plus 1. Half plus 1 is what? It's like, let me write it back. So it's like you got half A and this is half B, right? So
Sorry,
half A
half
plus
what?
A. If you got half of a cake and then somebody give you a whole of a cake, you get half of a cake.
Sorry, 1.5.
Yeah, 1.5, right? So you can say 1.5 A plus half B, right? Or if you want, you can be 3/2 A plus half B, right? So half plus 1 would simply be 1.5. All right? Might go there?
Yes, sir.
Yeah. So it's just a simple combination of what we found earlier. You take half of that and you add A to it. And that's how you find this vector. All right, so Casey Clark is saying good. 1.5. Julius. Anyways, so that was it for vectors. So this was a nice refresher. Vectors. Vectors, it's simple, right? For some reason, students tend to fumble in these kind of questions. Vectors and matrices, but you know, most times these things won't have too much application. You don't have to do too much. It's just a matter of remembering how to work it. As relates to the other topic areas like measurement and so on, you gotta do some amount of application. These kind of vectors and matrices is just a matter of remembering what to do. Some amount of application as well too, but mostly it's kind of remembering and computational knowledge. All right, so let's carry on. Let's carry on to some factorization and some solving of some equations. We've been solving equations morning, but now let's tackle some questions directly related to solving equation and factorizing. So we have two nice and easy factorization questions, which everybody should finish in under 30 seconds. When you see these things, you should start smiling immediately and know that it's free marks. So factorize completely each of the following expression. So you have 1 minus 4h squared. So 1 minus 4h squared. I want to factorize this. When you think about factorizing, when you think about factorizing, you should be thinking about two factors multiplying to give you the original expression. Right? So how can we factorize this? 1 minus 4h squared.
Using the difference of two squares.
Difference of 2 square, right? So the difference of 2 square. First of all, we got the name itself, difference of 2 square. Difference meaning two things must be difference meaning subtraction. 2 meaning you have two terms, and square meaning you have two square terms. So we have 1 and we have 4h squared. We know we can multiply something by itself to give you 1. 1 by 1 will give you 1. And we know we can multiply 2h by 2h to give you 2h squared. So it's a difference of 2 square. Difference meaning subtracting. 2 square meaning you have two square terms. Right? That is the name of the topic is in how you work it and what to look for. So we know these kind of questions go for 1 mark because it's simply one step. So you can open two brackets and we think to ourselves, what can we multiply by itself to give you 1? We know we can multiply 1 by 1 to give you 1. So it's 1 there and put the 1 there. And then we look at the Then we look at the 4 square term. What can we multiply by itself to give you 4 square? We see we can multiply 4h squared. So we see we can multiply 2h by 2h to give you 4h squared. So we take a 2h and we put it here, and we put a 2h here. So we 1 plus 2h, 1 minus 2h. One bracket you add and the other one you subtract. All right. So that is it for this question. All right, so that's it for that question. For the next one, PQ minus Q square minus 3P plus 2, sorry, plus 3Q. See somebody saying FU says, really comment gone. Start earlier. Gone. Comment gone. Okay. All right, so we want to factorize this, PQ minus Q square minus 3P plus 3Q. We have 4 terms. How can we factorize? So how do we factorize 4 terms?
You can group it first.
Yeah, we pair off, right? We pair off. All right, so we pair off. And then we factorize the force bracket. What is common in the force bracket?
Q.
Q. So we see Q is common, so we factor out the Q. So we factor out the Q from the force term. What is left?
P minus Q.
So we factor out Q from the force, and we left with P minus, we factor out Q from Q square. By the way, when you're factoring out, it means you're dividing, right? You're dividing the term by the factor. So we divide Q by Q square by Q. So this Q will cancel to one in the Q. We're just left with Q. And then the second bracket now, what is common in the second bracket?
Three, sir.
3 alone?
-3.
-3. Now, a key thing to look for when you have when you see a negative, when you see a negative in front of the term, you want to factor out that negative sign, right? When you see this negative here, factor out that negative all the time, right? So you always factor out that negative. So it will be negative, and then we see the common number would be 3. So the -3. And we factor out -3 from this forest term, we see we're simply left with P. And then we factor out -3 from this term, we're left with
-Q.
-Q, right? Because 3P, sorry, 3Q divided by -3 would be, the 3 will cancel out, and a positive divided by a negative would be a negative. So that we have -Q or -Q, somebody may want to think of it. So the important thing, we see our 2 brackets are the same. See, we see our 2 brackets are the same. That means, we did something correct. And then the last step is to take what is outside the bracket and put it in a bracket. So we have Q minus 3 in one bracket. And we take what is inside the bracket and we bring it down. So this will be P minus Q. And that's how you get your 2 marks. All right, simple as that. Everybody go there?
Yes, sir.
Yes, sir.
Oh yeah, they are blowing. Anybody blowing? Anybody tired? All the marathon, we've been at it for how long? I think we've been at it. How long I think we've been at it for?
Oh, and a half.
1 hour? Oh,
2
1 hour
hours,
and a
30
half?
minutes.
2 hours, 30 minutes. See? So much is fun. We've been at it for 6
1 and a half.
hours. We've been at it for 6 hours. Anybody believe that? I just joking. It's not been 6 hours. It's been 2 hours. All right, we hit the 2 hours mark. Yes, Nicola. 2 hours. For me, it felt like I felt as though we just locked on. I don't know. Anybody else felt the same way? Or just me alone? Me alone? Yeah, leave me hanging. Okay.
No, sir, me too.
All right. All right. So yeah, it's been 2 hours. It's been 2 hours. 2 good hours, 2 productive hours. So I think we come into the ending part. I mean, it's a marathon. Let me call a name, and as somebody said to me that they will stay here for the full thing. That person still here? Yeah, Nicole is in. It felt like a 30 minutes. All right, so let's carry on. So we want to solve each of the following equations. So let's see. Let me draw down this line. And let's solve the first one. So we have the first one, which is 3 over 2, sorry. 3 over 2y is equal to 12. So we want to solve this. So for me, I would have written this 3 over 2y. I would have written as 3 multiplied by y, all divided by 2 is equal to 12. And then this is a much more easier, it's easier to solve from here. All right? Which then you could have simply multiplied this here by 2 over 3, and you multiply this side by 2 over 3. But you know, whichever way you want to work it. But I would have simplified it like that. Then I know this 2 is dividing. So I take it over to multiply. So we'll have 3y is equal to 2 times 12 would be 24. And then y would be equal to, this 3 is multiplying the y. So we take that over, it will divide. So it will be 24 divided by 2. Sorry, 3. Y will be equal to 24 divided by 3.
8.
8. So our answer is y is equal to 8. All right? As Emmanuel says in the chat as well. And Casey Clark, or Cassie Clark. Anyway, so yeah, so that is it for that one. I think this went for how many marks? 1, I guess. And this one probably went for 2 marks or 3. So the next one we want us to solve is 2x squared plus 5x minus 3 is equal to 0. What kind of equation is this?
A quadratic equation.
A quadratic equation. So how can we solve this?
You can use the AC method.
We use the AC method, or we can even go and use the quadratic formula, right? For me, I know many y'all like the AC method, so we'll use the AC method. So let's use, well, we factorize first and then we solve. And that's why we use the AC method. So let's use the AC method. So let's identify what is A, what is B, and what is C. So what is A?
2.
2, and B is 5, and C is
2. 2, sir.
C is
Negative 3.
negative.
Negative 3.
Yeah, negative 3. So we got A, we got B, and we got C. So let's multiply A times C since we're using the AC method. So A times C would be 2 times negative 3, which would be 2 times negative 3 would be negative 6. So AC method, since we're doing a revision, AC method. Somebody tell me, give me a little something on the AC method. What are we looking for?
You're looking for 2 numbers that when you multiply A and C, it must be equal. When you multiply the 2 numbers, when you multiply A and C, and when you add it, you must get B.
Excellent. So the 2 important things we want to look at is B and C. So we're looking for 2 factors, 2 numbers. When we multiply these 2 numbers, as I said, we must get negative 6. And we add these 2 numbers, we must get 5. All right, we must get B. We must multiply them, we get AC. What is the value of AC? When we add them, we must get 5. So this will be A times C. So what 2 numbers you have in mind? What 2
Sir, 6
factors?
and negative 1.
6 and negative 1. All right, let's switch it wrong. Let's do negative 1 times 6 would indeed give you negative 6. And negative 1 plus 6 would indeed give you a positive 5. So these 2 are 2 important things we're looking for. So we'll use negative 1 plus 6. So we substitute in negative 1 plus 6 for this middle term here. All right, so this will be 2x squared minus, now we got to attach to the 1 and the 6, negative 1 and 6, we got to put x, right? So 2 minus negative 1x, which is the same as negative x, plus 6x minus 3 equals 0. Now, the whole purpose of doing that is to find 2 suitable numbers to replace 5x. And the two suitable numbers must be two numbers when we put it inside the, well, two terms, sorry. When we put it inside of the equation, it should not change the value of the equation. So we don't want to change it. We just want to expand it into four terms so that we can factorize it like how we factorize these four terms at the top here. So that is what we're doing, right? That is why we do the AC method and we look for A and C and two suitable factors and so on. All right, other than that, we could have put any number, but we want two numbers. When we put it inside the equation, it should not change the value of the equation. Because if it change the value of the equation, that means you're solving a different equation. Anyways, that is just some background as to the two numbers. So next we do like what we did just now. We pair off, and then we factorize. So we see 2x squared minus x. We see the common factor there. We see the common factor is x. When we factor out the x from the 2x squared, we left with 2x minus. We factor out the x from the x, we just left with x divided by x is 1. Plus, you see 6x and minus 3x. We see the common factor there. Between 6 and 3 would be 3. So we factor out the 3, and we're left with 2x minus 3 divided by 3 is 1, and that is equal to 0. So we take what is outside the bracket, we put in the bracket, so we have x plus 3 in a bracket, 2x minus 1 in a bracket equals 0. And then the question asks us to solve. So we solve. So they didn't ask us factors, they said to solve each of the following, right? So we have to solve it, meaning we have to find what is the value of x and y. So we take it a step further from here. So we equate both brackets to 0. So to be x plus 3 is equal to 0, and 2x minus 1 is equal to 0. So x plus 3 would be equal to x is equal to negative 3. And 2x minus 1, that would be 2x is equal to, this 1 is subtracted, and we take it over to add. So you'll have 1 plus 0 would be 1, and x will be equal to, the 2 is multiplying x, and we take it over to divide. So we'll have 1 divided by 2, which is a half. So x is equal to 0.5. Or you can leave it as a half, it doesn't matter. Unless they said to express your answer as a decimal, it doesn't matter. So we can say, therefore, x is equal to negative 3, and x is equal to 0.5. All right. But go there. Head over to YouTube and see what is happening.
Yes, sir.
Okay, so we have a few courses on YouTube as well. Okay. Yes. The YouTube got some fancy names. Anyways. Yeah, so that is it for that. So let's see what else we have here. We have some statistics. So we completed algebra, we completed trigonometry, we completed what else?
Functions.
Functions. Yeah, so we're doing some statistics. Every lap, every topic that we cross, we call it a lap. We done about 4 laps. Vectors as well, yes. Vectors and major C. The manual sub in the chat. So statistics is probably is a light part for most students, as it looks fairly simple, but the simple stuff is what would cause worry. So we don't want to take it for granted. So it says, let me get somebody to read it. I've been talking all the time. Somebody read the instruction for it. Anybody?
60 students took an algebra test which comprised 15 multiple choice questions. The number of correct answers that each student obtained is recorded in the table below.
Oh, sorry. Continue.
Using the table, determine the number of students who had exactly 30 correct answers.
Good. So how many students had exactly 14 correct answers? Exactly. Me ask in let me see what's going on. So somebody who's been looking at us from starting. How many students have exactly, let me zoom up, 13 correct answers? Let me see who can comment it. Right. So Nicola is saying 11. Yeah, so that's correct, right? 11 students. You can say 11 students. Right, because simply number of correct answers 13. Number of correct answers 13, and we see 11 students had that. All right, 11. Yeah. Next one. The modal of the correct answers. So what is mode or modal? What is mode again?
The one that occurred the most.
The one that occurs the most, the mode, right? The one that occurs the most, highest frequency. So let me see. I can send in the chat again. The people on Facebook. What is the mode? In the meantime, let me hear from somebody. What is the mode by time? So somebody saying 9. Manuel is saying 9. Katrina is saying 9. So let's see. 9. 9 has 14 number of correct answers. All right. But is saying 9. Anybody disagree with that in here? Or we say this 9, right? Yeah. Oh yeah. Sorry, my bad. My bad. So yes, 9. So 9 students, 14 students got 9 correct answers. So yeah. So we can say 9. So 14 students had, the most students had 9 correct answers. All right. Excellent. Next one is the median number of correct answers. The median number of correct answers. So for our 2 modal number of correct answers, we see 14 students got 9 correct answers. So 14 will be the most, right? Anyways, so next one, the median number of correct answers. So this one you got to do some amount of thinking. Median number of correct answers. What is median again? What is median again? Outside, because inside is too hot. What is median again? Anybody? Middle. Manuel is saying. Middle, yeah,
Sorry, the
middle.
middle number.
Yeah, the median is the middle number, right? So let's say we had 2, 6, and 10. Median here would simply be 6, right? So the median would simply be 6. So we want to find the middle numbers. Middle number. So the formula that we can use to find median when we have large numbers. For example, we have three elements here, or 3 members, or 3 numbers. So if when we have large numbers, we can use the formula n plus 1 divided by 2. N would be the number of elements that you have, or the number of people involved in the question or whatever. So this would be n plus 1, which would be 3 plus 1 divided by 2. 3 plus 1 divided by 2 would be 4 divided by 2, which is 2. So the second element would be the median. In this case, that is how we find 6 is the median. All right, so this will help us when we have a very large population or sample. Anyway, so we got to find the total number of students. So we got to add up all of this here to find the amount of students in this sample. Actually, no, we don't have to. We don't have to. We know it's 60 students. So it will simply be 60 plus 1 divided by 2. So 60 plus 1 be 61 divided by 2. It should be 61 divided by 2 would be 30.5, right? So this would be between 31 and should be between 30 and 31. The median between here. So we gotta find the 30th and the 34th student. The 30th and the 34th student, and then find the middle of that. So let's see the 30th. So let's see where the 30th will fall. So do we know 6 plus 14 would be 20? 20 plus this would be 22. 22 plus 6 would be 28. 28 plus 2 would be 30. So here would be 30. And so it will be between here. Right? It will be between 12 and 13. Because that's the position where it falls. So the median would be 12 plus 13 divided by 2. Right? This thing that we found here is the position in which the median is. Not the exact median, it's the position. Right? It's the position that you can find the median. N plus 1 divided by 2, that is the position. So when you count the numbers, that would give you the position. So we see it falls right in between. Let me do it again. 6 plus 14 will give you 20. 20th student. 20 plus 2 would be 22. 22 plus 6 would be 28. 28 plus 2 would be 30. So this is the 30th is here. And then the 34th would be right here. So it will be between 12 and 15. All right? If you write out all these numbers, that's we can get that. So 12 plus 13 will be 15 divided by 2, which would simply be 7.5. 7.5. Everybody go there?
Yes, sir.
Sir is not 25.
25. Where you got 25?
12 plus the 13.
Good, man. We got divided by 2, right? So you gotta find it falls in between the 2. Remember, it's like if you have the number 2, 3, 4, and 6, right? And you want to find the median here, right? The median would be these two numbers, right? So it would be between these two numbers. So what do you add up 3 plus 4 divided by 2? 3 plus 4 is 7 divided by 2 is 3.5.
So
Sir,
it's
but
saying that 13
12
plus
plus
12 is 25,
Yeah,
is
yeah, my
25,
bad.
divided by
My bad.
divided by 2.
My bad. Oh, yes. My bad. Sorry.
So you get 50, sir.
My bad. It's the marathon, the stumbling. Yes, that is correct. Yes. Maybe 25 divided by 2, 12.5. The coach is stumbling, right? Coach is stumbling, the other participant. Gotta come and help the coach. Yeah. So that's correct. Thank you, Tacito and Elizar. Yeah, so the median would be 12.5. Yes. So don't do like that. Don't do that in your exam. Double check. So the last one, the probability that a student chosen at random had at least 12 correct answers. At least 12 correct answers. So let me erase. So at least 12 correct answers, meaning at least we can have 12 and more, right? So we got to take all the students from here. At least 12. So at least 12 would be 2 plus 11 plus 9 plus 10. And 2 plus 11 plus 9 plus 10 will give us
32.
32. So 32 students had at least 12 correct answers. So the one the probability that if I choose a student at random, it will be either one of these 32 students. So to find a probability that if you choose a student at random, it will be the total number of favorable outcomes, which would be 32, 32, divided by the total number of possible outcomes. And that would be the students that we have in the class, the total number of students that we have in the class, which would be how much? How many?
60.
So 60. So 32 divided by 60 would be, let's break it down. So let's do,
0.5, sir.
yeah, 0.533. So let's break it down. Let's put in a fraction. So what number can go to 32 and 60?
2.
2. All right, 16. And then we got 30. And we can break this down even further. 8, and you can have 15. It's 8 out of 15, right? 8 over 15. 8 out of 15, right? At least. Wait, hold up. Is that correct? At least 12 correct answers. Yeah, at least. At least 12 correct. Meaning,
So it
at
must
least,
go over 12. Huh?
yeah, if you want at least $100, yeah, it can be 100 and more. If somebody say you gotta bring at least $1,000 to buy something, $1,000 gonna be the least amount, right? It can be 1,000 and more. Yeah, so that's one way you can think about it. Yeah, at least. Everybody go there? Everybody go there?
Yes, sir.
Yes, sir.
Let me see. Yeah.
At
That is,
least
that is, that, yeah, that is one way you can think about these kind of questions, right? If you kind of get confused with the difference between at least and at most, I think, put yourself in a situation. Somebody selling a phone, they say, hey, you gotta bring at least 32,000. Meaning you can't walk with 15,000. The least amount you could bring is 32. So you could bring party, you could bring, Yeah. So that's it for that kind of that question. Let me see who's going on chat. Nobody's seeing it. So we continue with our statistics. So let me get somebody else to read this one. I think I'm get another volunteer. Right, let me drink some water. Anybody?
Sir, can I read it?
Yeah, go ahead.
A group of students wrote a physics examination. Each of the students achieved a grade I, 2I, IV. The pie chart below shows the results.
Okay. So grade 1, grade 2, grade 3, grade 4. Right? So the pie chart show get grade 1, I'll get grade 2, I'll get grade 3, I'll get grade 4. So let's see. 39 students achieved a grade 3. So determine the number of students who wrote the exam. So 39 students achieved a grade 3. And they want us to determine the total number of students who wrote the exam. How can we find that? How can we find that? If 39 students 39 students achieve a grade 3, and they gave us some information about these 39 students. They gave us some information here. How can we find how many students wrote the exam? How many degrees did 39 students took up?
117, sir.
So 117. So how can we find the amount of students here? Out of the 117 degrees, let's 39 students. How can we find total number of students? So we can say 39 multiplied by 360 which is the total number of degrees in the circle, divided by 117. That is the amount of students that the 39 students will be, the amount of degrees for the 39 students. This will be 39 times 360 divided by 117. And that would give you 120 students. Students. Remember, 360 is the total number of degrees in the circle, and 117 is what you have already. So, you know, you put the 360 over that and multiply by 39, that will give you total number of students. All right? There are other ways you can do it as well. Anyways, everybody go there? Everybody go there? Let me see.
Yes, sir.
Yes,
Yes,
sir.
sir.
All right, so the next one, the ratio of the number of students who achieve a grade 1, 2, or 4. All right, good. Ratio of students who achieve a grade 1, 2, or 4 is 2 to 4 to 3. A student passes the exam if he or she achieved a grade 1, 2, or 3. How many students pass the exam? So they gave us a ratio of grade 1 to 2 to 5. And that ratio is 2 to 4 to 3. All right? So they wanted to find how many students pass the exam. So they didn't give us grade 3. So that means this ratio here, it doesn't cater for grade 3. So what we gotta do, we gotta take out the number of students who achieve the grade 3. So we know we have 120 students in total, minus the amount of students who got the grade 3, which is 39. That would equal to 120 minus 39. That would be 81. So this ratio caters for 81 students because it's grade 1, 2, and 4. So they told us this ratio is 2 to 4 to 3. So let's find what each one of these ratio is worth. Each part is worth, right? So 2 to 4 to 3. That would be 2 plus 4 plus 3. And 2 plus 4 would be 6. 6 plus 3 would be 9. So it's 9 is the total share. So to find the value of one of these shares, it would be 81 divided by 9. So 81 divided by 9 would be 9. So that is the value of one share. One share is equal to 9. So to find the amount of students who pass the exam, we gotta find the amount of students who gain a grade 1 and a grade 2 and a grade 3. So let's see the amount of students who gain a grade 1. So the share for the grade 1 is 2. So grade 1, it will be 2 multiplied by the value for one share, which is 9, which is equal to 18. Amount of students who gain a grade 2 would be, how many is the share for grade 2? 4. So it would be 4 multiplied by 9, which would be 4 9s, 36. And then we already know the amount of students who gain a grade 3 because it told us it's 39. The amount of students who gain a grade 3 is 39. So to find the amount of students who pass the exam, we add up all of this. And 18 plus 36 plus 39. How many students pass the exam?
93.
93 students pass the exam. So we can say, therefore, 93 students pass the exam because you can pass the exam if you get a grade 1, 2, or 3. So we're dealing with grade 4, right? Pass the exam. All right. Everybody go there?
Yes.
So last but not least, determine the value of the angle for the sector representing grade 1 in the pie chart. So you want to find an angle now. So So we know the amount of students who gain a grade 1 is 18. So it will be 18. So let me write this. Number 3. We know 18 students gain a grade 1. So it will be 18 divided by what? What are we dividing the 18 by? 18 divided by how many? This is the total number of students we have.
120.
18 divided by 120. And we're multiplying this by to find the amount of degrees that this 18 will take up.
So 360.
Yeah, 360. All right, 360. It's 18 times 360 is equal to 6,080, 6,480 divided by 120. That would give me 54 degrees. It's therefore grade 1 is equal to 54 degrees, all right? And that is it for that one. Ready to go there?
Yes, sir.
Yes, sir.
Mhm. So let's go. Yes. My friend from Region 1, them on. Friend from Port Kaitumo. Where are you? It's the pier.
Yes, sir.
All right. Are you buckling? You're buckling or you're running strong?
Still going strong, sir. Going strong.
Going strong. You start off hot and sweaty and all right. All right, Dara, let's go.
Same
Let's
way.
go. Arlene, read this for us. Read the instruction for us.
Right,
Or
so
two.
the mass M.
Mhm.
Sir? All right.
Continue,
The
sorry.
mass M in kilograms. Right. The mass M in kilograms of 120 newborns at a hospital is recorded in the table below.
Good, thank you. So we got the table below and the frequency and so on. The frequency tells you the amount of babies that fall into the range, the group data. So we got 2.6 to from 2.6, 3.5, and so on. So stay the modal class. So what to be the modal class here? What will be the modal class? Which one got the highest frequency? Let's see if anybody said it in the chat. Yeah, so Emmanuel said 4.4, 5.3. Yeah. So yeah, this is the modal class. This will be 4.4, 5.3. All right. Nice and easy one. Mark. Is it? What? So complete the table below and calculate the estimate mean mass of the 120 newborns. We gotta complete this table. So I will complete it. So you don't have time to draw it. So no, the thing about these tables, right? What I would encourage persons to do. You see like how they already gave you this answer here, they already gave you the midpoint here, they already gave you, the frequency times the midpoint. What you can do, let's say you can't remember how to find midpoint for some reason. What you can do, see what they use on the table and see how you can find midpoint from what they did in the table. So what you can do, you can just take these two numbers and see if when you add up them and you divide by 2, see if you'll get this. And that's how you can check, and then you use the same thing and you find for this here. All right, so you can check 2.6 6 plus 3.5 divided by 2. And Babs, you know, you have that answer. But that's what you can do. One tip, you know, if you're given a table and they already completed parts of the table, for some reason you can't remember how to work out, try to see what they did. Anyway, so the midpoint for this here would be 5.3 plus, for this one would be 5.3 plus 6.2, all divided by 2. And that will give us a value of 5.75. And the same thing here, 7.1 plus 8 divided by 2 give us 7.55. All right. And then the frequency times the midpoint, which is fx. So it's basically this number multiplied by this number. So it will be 5.75 multiplied by 29. And we can see they wronged it. All right, so this would be 166.75. And the same thing here, 7.55 multiplied by 8. That will give us a value of 60.4. All right, and that is how you complete the table. Easy marks, easy giveaway marks. Any completed of any table, you know, you should maximize on the amount of marks for those. All right, maximize on those marks. 1 second. All right, so that's how you complete that table. And the next one says, a newborn is chosen at random from the hospital. Find the probability that the newborn has a mass greater than 5.3. Greater than 5.3. 5.3, so we have 5.3 here. We want to find greater than that. The probability that if you choose a newborn at random, the newborn has a mass greater than 5.3. So anybody here in here, how can we find that probability? Our probability is the total number of favorable outcomes divided by the total number of outcomes. So what can we do there? Anybody here? Or in the meantime, anybody can type in the chat while waiting on somebody here. What can we do? Greater than 5.3.
Sir, add and then divide.
All right, so we add in which set of numbers?
The midpoint times frequency.
You sure it's the midpoint? Midpoint will tell you the midway, right? Midway between the thing.
No, it's midpoint times frequency, sir.
Greater than 500.
I mean, what the frequency tells you? Frequency tells you what?
So we add in the frequency times midpoint.
All right. So you're wrong. The frequency tells you the amount of babies that fall into the range, right? So if you want the amount of babies who gain mass greater than 5.3, you gotta add up all the mass, all the frequency greater than 5.3. So the frequency will give you the amount of babies, right? So you gotta add as Manuel says 29 plus 28 plus 8. So to be 29 plus 28 plus 8. $65, right? So it's 65 babies got mass greater than 5.3. So, but we want to find the probability. So remember, probability is the total number of favorable outcomes, which is 65 in this case. That is the amount of babies we can pick, and the total number of outcomes, which would be 120. So the probability would be 65 divided by 120. So 65, 120. So we can break this down. And one number can go into 120 and 65.
5.
5, so 5 divided by 65 would be 13. 120 divided by 5 would be 24. So it would be 13 out of 24. Right? Yes. 13 out of 24. So 13 over 24. So 13 divided by 24. It would be 0.542. But you can leave it as a fraction, you know, it looks nicer. So 13 out of the probability is 13 out of 24. But if you choose a baby at random, the baby has mass greater than 5.3. The probability of choosing a baby at random with mass greater than 5.3 is 13 out of 24, 13 over 24. All right, so that's it for that one. So last but not least, well, for this part, complete the cumulative frequency table. Cumulative, when you hear the word cumulative, means you keep adding on. Cumulative, when something accumulates, it keeps adding and building and building and building. So for the cumulative frequency table, you keep adding from the previous number. So this will be 7 plus 18. That will give you 25. Then it will be 25 plus 30. That will give you 55. That will be 55 plus 29. 55 plus 29 would give you 84. Then it would be 84 plus 28. 112, and it would be 112 plus 8, which will give you 120. And at the end of all of this, you should get the total number that you have here, 120 newborns. So you should get 120 when you add up all the cumulative, when you reach the final number in the cumulative frequency. All right? So you should get 120. So that's how you complete that beautiful table here. Nice and easy marks. Everybody go there?
Yes, sir.
Like, you're blowing, man. You're blowing for this marathon. Anybody blowing? Who blowing? Who out of breath? Who is out of breath?
Sure, me.
Who's that? In any case, you're out of breath?
Sir, hungry.
Hungry? Oh, you want to come this marathon without eating, man? Well, at least to come to this marathon without eating. All right, so let's see. I think we got one more. Oh, this is we're on the last page. So this is the last one. All right, and we'll stop. All right, we'll stop here. We'll stop here since, well, after this last one, and then next time when I come to this marathon, I'm sure I'll eat something. Who else blowing and tired?
Sir.
I see.
Yes, sir.
See all these persons that told me, hey, sorry, I can make it till 3 o'clock. So far, the more sorry, you can go till nighttime while we can stay, we can work. Yeah, I like
Thanks,
that.
sir.
Yeah, I like that. These people that would run these races, you start up at the first lap, full pace and power. And by the second lap, you start hold your back. All right, let's go. Last one. So we want to we actually made it to the last question. So let's see. So on the grid, draw the cumulative frequency curve to show the information in table BI, which is which is this one that we did here, right? So we're using the upper limit. This is the upper limit they use. Yeah, we're using the upper limit and the cumulative frequency to plot this cumulative frequency curve. So when you plot a cumulative frequency curve, it should come like this. All right. Should come something like this. All right. That's when you plot it. So if you plot a curve and you curve something, your curve looks something like this. Let me see. The curve looks something like that, or your curve looks something like that, that means it did something wrong, right? Cumulative frequency, it should continue going up and up, right? And it should look something like an S like that. That's how it should look. If you look anything different, it means there something wrong with the curve. All right, so let's go. So you see, the thing is, watch how CX is nice, man. They even plotted the forest tree for you. They plotted the forest tree for you here, here, and here. You know, they're so generous. So next you got to plot is the 6.2 and the 8.4. So we go 6.2. See, here is 5.5. I guess here it'd be 6. So 6.2 would be here. And we got to go up 84 times. So we go straight up to 80, 82, 84. So 84 would be here. All right. Yeah. And then the next one, we go across 7.1 times. And we go up 112. So 7.1. So here is 6.5. Here it'd be 7. 7.1 would be here. And then we go up 120 times. 120, 120, 112, sorry. 112. So here is 100. So 112 would be A, right above the 100. Since we're counting in twos, 2, 4, 6, 8, 10. All right, 2, 4, 6, 8, 10. Yeah. The last one, 120. So it will be 8 all the way up to 120. So 8 is, if here is 7.5, here would be 8. And we go all the way up to 120. So 120 would be right here. So let me connect now. See where S will come a bit nice. Yes. Let me use this last piece.
So you put the second to last point wrong.
I did. Let me see. 8.
Sir, it's supposed to be 112.
Yeah, 112.
112. And what did I plot? Oh, yes, yes, I
One,
did.
two.
I did. I did. So it will be 112. I plotted 102.
Sorry, you want me to start?
No. No, I can like yeah, I could go till I could work until tonight, you know, but in because yeah, we'll stop here. Let me see 112. So it would be 7.1 straight to 112. So this is 110. So here would be it, right? So let me connect now. And I can go until you said the curves look nice now? Yeah. So indeed we plotted it wrong. All right, so that is it for that. I think this will probably go for about 2 to 3 marks. So we want to ensure you plot your diagram correct. Use the upper limit and the cumulative frequency to plot it. All right. And that is that. Everybody go there? Everybody go in the chat. The people, let me see. Anybody in the chat stayed from start to end? I know, let me see. Let me see the name. Let me see the name, I don't know who's the individual. Nicola and who's the other person? Emmanuel. All those persons were in since the beginning and few people dropping. Anyways, so that brings us to the end of our marathon. So students indicated that they're buckling and they're out of breath. So we'll have to cut the mark. We'll have to stop the marathon here. We'll come back again the next time before the exam and probably work some paper one type questions. Anyway, so that being said, y'all take care, enjoy. Y'all have to keep practicing for the maths, keep practicing. And there's also a WhatsApp channel that is available that I came across that's very helpful. So let me paste that link to that channel in this right in this link here. So you have to join the channel. Some resources and so on are sent. All right, so let me share it. Let me paste it in the chat. So you can probably check back that comment at the end of the video and click on the link to join this CSEC Math Prep channel. Some nice resources are sent there. All right. Anyways, that brings us to the end of this. So take care. So my students, you could stay on after I end the live, right? Stay on, don't leave.